Hello everyone, this is Robin Short with the Worley Training Department. Welcome to the video training today of investigating water losses and remediation. So there's several ways to approach a water loss and to remediate it. So we'll talk about water remediation at the end of the video, but first let's set up our claim that we would understand how to investigate a water loss. So first of all, we'll get this out of the way here so we can see what's happening on the presentation of what type of non-water losses are there. There's broken water lines, broken drain lines, leaking AC condensers, leaking appliances or appliance water supply lines, drain and sewer backups. So each one of these types of loss can deal a little differently than the next. Let's talk about what category of water there are. There's actually three. Category one is a clean water break. This comes from your water supply line breaks, your clean water lines to the home. It's actually drinkable. You wouldn't want to, of course, but there's really not many contaminants in it. Category 2 water, now we're dealing with contaminants. We are talking about a degree of chemical and biological physical contaminants that if you would drink it, you would get sick. It's called a gray water. Gray water comes from soapy water, maybe from a dishwasher overspill or a type of water that actually can move from a clean water to a gray water would be water that would flow through a floor from a second floor to the first floor. The first floor now would be considered gray water. It's picking at contaminants through the walls, through the floor, that type of thing. And then we have the category 3 water, which is black water. This is your sewage backups. Very harmful, unsanitary agents, a lot of bacteria, a lot of fungi. You get the picture. Black water comes from the sewage. Now there's also what we call the class of water. So there's 4 classes, and they deal with evaporation. Evaporation meaning drying techniques. So the first class is a slow rate of evaporation. It affects only a portion of the room. Materials have low porosity. Minimum moisture is absorbed by the material. So this is like a partial water, like maybe a kitchen supply line breaks. It only gets half of the kitchen wet. It's still a bottom up type loss, but the entire room is not impacted. Now class 2, a little bit faster rate of evaporation. Water affects the entire room. Maybe some carpeting, the carpet pad, it's wicked up the walls, but no more than 2 feet, 24 inches. So that's a class 2. Class 3 is water generally comes from overhead, affecting the entire area, walls, ceiling, insulation, carpet pad, those type of things. So the entire room has been impacted. It's a top-down leak. I have seen water lines that run through the attic, especially in the winter. They freeze. The water lines freeze and burst. The water comes through the ceiling all the way in through the wall. This would actually be considered a gray water, and in some cases black water. Class 4, now we're dealing with specialty drying things. These are things that have a high porosity on them. These are such as hardwood floors, concrete, crawl spaces, plaster. This takes a special type of drying to get these hard surfaces dry. Now when you're investigating water loss, you want to make sure that the 3 components of your product is all in line. First component is your narrative. So we want to explain everything. What happened, who was where, when did they see this, who did they call, when did they come, how did they dry, how much time were they away, when the discovery was. We want to make sure all the details are really laid out in our narrative. Photos, that's the second component. We want to show not only the water damage, but the source of the water. Where did the water discharge come from? Was it Was it a sewage line? Was it a freshwater line break? Was it a supply line? Was it an appliance? So we want to make sure that we are really documenting everything that we possibly can here. And finally, the sketch piece is when you diagram, sketch your floor plan. Make sure that you're putting some type of arrows or highlighted lines in the rooms of where the water came, how far the water traveled. All of these diagrams are giving evidence of why the drying techniques were used in the particular case, or in another way, overused. So everything has to be documented, everything has to be photographed, and lay out your sketch. Investigation. Hey, make sure you're asking the right questions. What happened? What did you do? Who did you call? When did they arrive? What did they do? How far did the water travel? Did you take any photos? If you talk to an insured and they said, well, I found the water on the floor. Well, when was the last time he was in the room? When did you come back? I went to bed. I woke up. So how long did you sleep? 4 hours? 14 hours? We need a timeline because this all impacts the way we would dry. Or how long material has been exposed to moisture or water. So if there's a mitigation company involved, when did they come? How many pieces of equipment did they set up? Sometimes you're going to get there, remediation's already been there and left. So now you're left to deal with the remediation company trying to get their photos and dry logs and things like that. But ask the insured, how many pieces of equipment was in this room? They can oftentimes tell you, and sometimes they are the best source to rectify that remediation invoice. Okay, so now we're going to scope and estimate. This is, again, pretty basic, but you want to start where the water discharge came from. Start in that room and then work your way out where the water went. Just don't start in any room, but start where the water damage started. And then in each room, a good way to do this is just to separate, outline the ceiling, the walls, the floors in your estimate, so everybody knows what is wet, what was damaged, where things happen. Follow a sequence. Make sure that if you're outside in or top down, make sure that you just don't start firing off photos, but make common sense. If the water discharges from the floor and it went up, start from the floor. Don't take an overview of the ceiling and then go to the floor. Start where the water started and then work your way with where the water went. I think it's a good practice. Just get in a room, finish the room before you start the next room. Don't be bouncing back and forth, and a lot of times the insurers are highly agitated, or they're panicking and they want you to just go through the rooms. You take charge. Make sure that you don't miss anything. Double check your product ID, the sizes. Make sure that you've got the right material, that you're notating everything that is damaged. Depreciation is based on the actual age. Make sure that you got your depreciation done based on age and conditions or normal wear and tear. Some carriers want a minimum charges, others don't, but just check to make sure you've got your minimum charges as needed. Again, cause and origin. A lot of times we get this backwards. We'll say the cause of the loss was the broken pipe, and then we go to the origin. We're like, well, wait, it started in the bedroom. No, the cause of loss and a water loss is water. Water damaged the material, and the origin is where the water began, where the pipe broke, where the backup occurred, where the appliance failed. That's the origin. If it is an appliance failure, make sure that you get the serial number, model number, make on that, get the age of the appliance, so that we can properly think about subrogation. Subrogation is for defective parts. Sometimes we have water supply line break to the refrigerator, ice machine, let's say, and we don't go too far with that, but we need to ask, when was the refrigerator installed? Was the who installed it? Was the refrigerator recently moved, and who moved it? Because those could be subrogation potentials. Are there any ascribable negligence? Are there any third-party involvement? If the water line broke, when was it installed? If it's 25 years old, yeah, but it's probably wear and tear. But if it was installed 2 months ago, we could have a subrogation issue. Always think about salvage. Are there salvageable possibilities, contents, appliances, etc.? If there's no salvage, explain it. The damage of the hard property will be disposed. There you go. Now let's talk about water remediation. So attempt to understand the age of the plumbing, the appliance, or the unit from which the water was discharged. Attempt to understand where the water came from and how far it traveled. How deep was the water? Where did it go? Where did it flow? Attempt to understand the wet material, how long it was wet. So if the water line broke this morning and the insured left for work and didn't come back until 6 o'clock tonight, we know that it has been exposed perhaps 8-10 hours or maybe 30 minutes. So try to attempt how long material's been wet. It's going to affect our drying time. Attempt to understand who cleaned up the water and how long it took. Did the insured clean it up? If so, how long did it take? What did they use? Mop, buckets, towels? What did they use, and how long did it take them? This is kind of an important graph here. We call it the HAT. Humidity, airflow, temperature, and time. These four elements affect the dry time. Relative humidity and specific humidity are two different things, but what happens is humidity is measured in grains, and there is humidity is moisture vapor. Moisture vapor always moves from hot to cold. Example, take a glass of iced tea, you set it outside, it's a 90-degree day. What happens to the glass of iced tea? It gets condensation on it. So all of the hot, humid summer air is moving to the glass, which condensates on the glass. The moisture in the air condensates on the glass. Wintertime, your house is 70 degrees on the inside, it's 20 degrees outside, your house is cooling down. Why? It's not because the hot is escaping to the cold. So the hot air on the inside is trying to go to the cold air on the outside. Reverse that. Summertime, 90 degrees outside, and you've got it 70 degrees on the inside. So now all the hot air on the outside is trying to get to the cold air on the inside. So it always moves. Same way with weather patterns. The summertime, the heat heats up the ground. The ground releases moisture vapor. It moves up, goes to the atmosphere, creates a storm. Hot air is less dense than cold air. And so when we talk about humidity, we talk about airflow. The more airflow, the less humid it is. The hotter the temperatures, the more humidity. There's a time element all involved in this with how much time it takes to dry something based on temperature, airflow, and humidity. So that's how that works. The measurement of water vapor. So specific humidity describes the exact amount of water vapor present in the air. Specific humidity is commonly expressed in grains of moisture per pound of dry air, GPP or GR pounds. 1 grain equals about 1/7,000th of a pound. Standard sea level day, about 14 cubic feet of air weigh 1 pound. A pound of water, and or a pint of water, and a pint of water is about 7,000 grams, all about the same. Gallon of water weighs 8.34 pounds or 58,380 grains. So the grains is important to know because our dehumidifiers, they're registered on how many grains they can remove in a day. Now, this is a graph, size chromatic chart, relative humidity, dew points, the temperature, and how many grains per pound. So on a 85 degree day with a dew point of 75, you're going to have about 130 grains per pound. So if water discharged in a home and it put in an estimated of 50 gallons of water, you can compute that to how many grains that is and what kind of dehumidifying techniques you're going to need to get that water out of there. So this chart is kind of sophisticated. The point here I'm trying to make is moisture vapor is measured by grains. 7,000 grains equals a pound. Okay. Now here's your dehumidifiers. Now this chart shows it by square feet, but most of the, as I'll show you in a moment, most of the dehumidifiers are rated per pints they're going to remove in a day. Pints translate back to grains. In this particular case, you've got a 600 to 800 square foot space for this one, 800 to 1,000 for this one, and so forth. Here's the rating, ppd. That's a measurement of pints per day. So this would take out 57 to 99 pints per day. This one takes out, what's that say, 75 to 99 pints per day on that one. Now, with the dehumidifier, you have to have blowers, air movers, and we have several different types of air movers. The thing about this is that it takes about 4 air movers for one dehumidifier. One dehumidifier can take about 1,200 square feet. Just kind of trying to make it easy. If you got 1,200 square foot, that's a 10 by 12. Need one dehu in it and 4 dryers. That's kind of a rule of thumb. You want to place your dehumidifier in the center of the room, and you want to put it and you don't want to put them face to face. If you have 2 in a room, you want this air to start moving in a direction like this or in a direction opposite of one another. The more air movement, the more friction. The more friction, it heats up the air. The hotter the air, it will move to the cool. A dehumidifier is built with a condenser inside. It's a cooling condenser. So the hot air blows over the cooling condenser, it condensates water, goes to a drip pan, and there's a discharge line out of the dehumidifier, and that's the drying process. A couple photos showing these typical air movers. So we've got a rotation going this way and this one, and that's what you want. You want a circular rotation. We've got some specific drying here. So we've got a hardwood floor that we're trying to dry out. We've got blowers moving air into these jackets. These jackets are pulling up the air, and they are going into a dehumidifier. This is a top-down water where you've got blowers blowing up into the cavity, trying to move the air. You've got these blowers set up so they're in a circular rotation. Again, moving that air around, not just blowing it straight on the surface. Another picture showing this friction. You got 2, it looks like they're working against each other, but they're actually blowing it up in an area like this in a hallway. Another close-up of the floor drying technique. This is a commercial operation where you'd have you're moving the air outside with discant humidifiers, I should say. So we have two types of dehumidifiers. We've got the refrigerant and the desiccant dehumidifier. It's kind of hard to say. This is involving cooling the air below its dew point. Cooling the air increases the relative humidity, therefore decreasing the air's ability to hold moisture. The lower the relative humidity, the harder it is for the air to hold the moisture. So it blows into the dehumidifier over these condensers, causing that to evaporate. Now, desiccant dehumidification is a little different in the fact that here there's a motor inside this, and it actually heats the air right before it gets into this dehumidifier, and that is taking the air. It's hotter when it hits this machine, thus it evaporates quicker. So it's a system that is made for once the heated air hits it will go outside, as we've seen in this type of picture here. Okay, so let's talk about water remediation and some of the equipment. So the WTR-THM, that's your standard Exactimate code for a dehumidifier. If you look in the description of it, you'll see that this particular one pulls 69 pints per day. So that's the smaller one. If you need a bigger one, you just have to push the greater sign, and you'll get one that's 109 pints per day. So which one do you use? Well, it depends on the class of water and the category of water. It depends on what you're trying to dry. Is the material more porous? Is it if you've got carpet in a room that you're trying to save, you're probably going to need the larger one. If you pulled a carpet and now you're just on the subfloor, you don't have that moisture holding in the carpet, so you could use the smaller one. A couple of types of air movers. Centrifugal. We call this the air runs in this squirrel cage, they call it. The air moves in this way and blows out that way. It's kind of a spot-on type of air mover. This is an axle fan. This is a lot heavier duty type of air mover, used to move a lot of air. Bigger room. One of these would equal two of those type of things, but you need to move the air. That again creates the friction. Then we have we've called the HEPA filters. We have contaminants. Maybe this was gray water on this carpet. We got to pull out the contaminants on that. Maybe it was a black water. We pulled the carpet, but we still want to use a HEPA filter or a HEPA vac to pull any type of biological fungi, bacteria out of the surface on those. So those HEPA vacs are used with black water or gray water. Inspection and evaluation for restorability. So when you're thinking about the water and contents in particular, what was the category of water, the time of exposure, the basic material composition, the cost of restoration, the value or the cost of replacing the item, or the types of value, like sentimental, legal, artistic, cultural, historical. Those are important because we may not be able to restore them, but as I'll show you in a moment, there are ways to estimate for that. Contents is something that the way I handle it, I always worked the rooms first. So I went through all the rooms first. Then when I'm completely done with that, then I went back and inspected the contents. Went through the hard contents first, your furniture, things like that, appliances. Then you would get into your your fabrics, your linens and things like that. Water remediation, the types of services required for each content item may be categorized in these 3 ways. So when you're thinking about it, are we going to restore it? Are we going to dispose of it? Are we going to preserve it? So restore. So now we're going to try to dry it. We're going to try to clean it, resurface it, whatever we need to do to put it back in acceptable condition, if it's possible. If we're going to dispose it, we don't really need to dry it. Items that will not be cleaned because the owner has no interest in salvaging it or the value does not justify the cost of restoration, we're just going to dispose it. No sense to try to dry it, throw it away. We may have to preserve something, items that are irreplaceable but cannot be properly restored to an acceptable condition. Again, that's talking about your types of values here. These sentimental items or legal items. We're going to try to preserve it, but we know that we can't restore it. I threw an estimate, kind of some codes together, thinking of just scenario. Maybe this was a black water loss. It was after hours, so I just threw these codes in. We would allow for an emergency service after hours. We would, if it was a black water, we always want to make sure that the workers are, remediators are covered, personal protection, boots, eyewear, gloves. After they get the muck out, we would HEPA-vac everything. I used like a 20 by 15 room. I said the water was 4 feet up on the walls, so it's perimeter 4 plus floor. If we're using a HEPA filter, we want to change out the filter at the end of the operation. Water extraction remediation, I gave them 2 hours to do this, this work. Setup, takedown, monitoring after hours, I gave them a couple hours. Contaminant barrier, so if I've got a black water, I've got potential bacteria, fungi, might seal the door, put a zipper in the door, in the seal, if you will. So I give 18 square feet for a door. Go ahead and tear out the baseboard and bag it. Tear out the drywall 4 feet up and bag it. Tear out I'm just saying there might be carpet there. Tear out the carpet, tear out the pad, tear out the tack strip, apply the antimicrobial, again, floor, perimeter, and then I only set up 1 dehu, a small one, and 4 air movers. Again, I've got everything out of the room that was wet or was contaminated, so there's really not a lot to dry, but there's still heavy moisture vapor in the room, so I want to make sure that the porous floor is dry, any exposed wall frame would be dry, and I only give them 1 day for that. So it's kind of simple logic when it comes to the water remediation and water inspection. So in a lot of ways, I think that if you just approach it where you're where you're trying to find out how long was the water running, how long was it exposed, take your time and go through each room at a time, document everything, and then when you go to do your water remediation, if you're writing an estimate, the common logic is that you were, what are you trying to dry and restore? What is wet and can't be restored? You dispose of that. If you've removed all the wet material, there's really not a lot of drying needs to be done. So you just use your judgment on that. But hopefully these codes give you a couple ideas of what to do. The equipment gives you an idea of what to use, and understanding moisture vapor and how it moves with respect to specific humidity and grains per pound. So hope you enjoyed the video. Hope it helps in some way. Thanks for working for Worley. We appreciate you. Be safe out there. We'll see you on the next video. Have a good day.